In this video, I'm going to give you a simple explanation of how normals work. Normals are vectors that represent the orientation of a surface and are used for shading. For example, when a normal or surface points straight at a light, the strength of the light is the strongest, making it brighter, and as it points farther away, it gets weaker and dimmer. And based on the alignment of the camera, light, and normal, the amount of light reflected directly into the camera will change to create highlighted spots. With face normals, each face gets a normal pointing out from the face, perpendicular to the tangent, creating results like this. There's a problem with this method though. It can only create flat shading that won't look smooth without a ton of polygons. To fix this, you can instead add a normal to each vertex. For each pixel rendered, it interpolates or blends between the vertex normals surrounding the face, then to figure out what the normal for that point should be. This creates the illusion of a smooth surface. If you wanted to create a sharp edge, you could duplicate the vertices in the same place, and each duplicate will use its own normal pointing in a different direction, creating a split in the smooth shading. Your modeling program will do this behind the scenes for you by default automatically, just by having a sharp edge somewhere. Doing this for each vertex will recreate the flat shaded look you get with face normals. In Blender, you can mark some edges you want to split as sharp using auto smooth or the edge split modifier. In other programs, this is done using a different approach called smoothing groups, where you choose the groups of faces you want to shade smoothly in between. Modifying normals can help to improve the shading of certain models. You could use it to improve the shading of a cel-shaded model, such as a cartoon or anime-style character, to make sure you don't get the shadows in weird areas. It could also improve the shading of foliage, such as trees, where groups of leaves may be actually a single large flat plane. You can transfer normals from a sphere, can the shading look prettier. Another technique called face-weighted normals can be used to make nice-looking bevels without adding a lot of bevel segments. Simply point the normals in the direction of the large faces to cause the shading of the bevel faces to blend, an illusion of high poly bevel. And finally, we have normal maps. Normal maps are textures that use the red, green, and blue channels to store the x, y, and z components of a normal vector. These change the normals on the model to give it the shading of a higher detail model. Since it can only change the shading and not the actual shape, normal maps work best for small details such as scratches or small bumps that won't have much of an effect on the general shape and silhouette of the model. Otherwise, the illusion of a higher detail model will break. There are two main ways to make a normal map. The first is to create a height map, which is a grayscale texture where darker areas mean to go down and higher colors mean to go up, and use a program to convert the height map into a normal map. You can use a height map by painting it in a program like Photoshop, or procedurally create it in a program like Substance Designer, or even kind of just by changing a photo into grayscale can work in certain situations. The other method is to create a high poly model, likely with sculpting, and a low poly model, and bake or take and put the high poly normals into a texture for the low poly mesh. There are 3 different types of normal maps based on the space it uses as reference. World space normal maps are the most basic type of normal maps based on the normal's direction relative to the world. This comes with the advantage that it needs less calculations and can run faster, but it has disadvantages such as if the object is rotated, the shading will be incorrect. The texture also can't be reused on different meshes, such as using a tiling brick texture on different wall pieces. Due to the full range of angles, these tend to be rainbow colored. Next, there are object space normal maps, which take the rotation of the object into consideration so that the shading is correct when rotated. Object and world space use the same textures, with object space doing an extra calculation to correct for the rotation. Finally, there is tangent space, which are relative to the surface tangent. These modify the regular normals of the mesh, meaning that not only can the object be rotated, the normal maps can be placed on different objects, tiled and without problems. The shape of The model can even be modified, allowing for animations such as an arm bending or whatever on a character. Due to this flexibility, tangent space are the most commonly used type of normal map, followed by object space. World space isn't really used very often. Thank you for watching. If you like this video, please like and subscribe. Thank you.